Okay, so in this example, we are going to solve a trigonometric equation that is linear in form. So really quick to make it clear on what it means to be linear in form. You see how when we look at this term here, that the tangent function is raised to the power 1, right? Versus, let's see if I can find another one here, versus in this example here, where we see that the cosine function is raised to the power 2. So this would be considered quadratic in form, and when there isn't a square, it is considered to be linear in form, like the one we were doing here. All right, so now we want to solve, in this equation we want to solve for the value of q in the interval 0 degrees to 360 degrees. So whenever the equation is quadratic in form, what we do is we first isolate the trigonometric function. So I'm going to add the root 3 to both sides and then divide by 3. So I have root 3 over 3. Then we decide what quadrants these solutions can be in. So where can the angles, or where can the angle q, what quadrant must the angle q be in order for the tangent of that to equal a positive value? And so in that case, we can use all students take calculus and recall that all the trig functions are positive in quadrant 1, so q can be in 1, and then tangent's also positive in quadrant 3. The next thing we do is we find what's the reference angle that would correspond, or let's say, rather, what's the reference angle for q? We can do that by thinking about what common angle corresponds to root 3 over 3 for tangent. And so what I mean by that is, we know we have these special triangles. So let's say 1, root 3, 2. This will be 30, 60, and then you also have 1, 1, root 2, which of course is 45, 45, 90, and there's 9 as well. Now, what is root 3 over 3? Well, root 3 over 3 is the rationalized version of 1 over root 3. Okay, so which one of the basic angles corresponds to 1 over root 3 for tangent? That's right, so it's 30 degrees. So the reference angle is now 30 degrees. And then what I do is I simply put that in the appropriate place. And then we can see here that one of the solutions will be the answer that's in quadrant 1, which is 30 degrees. And then the other one is going to be the one that's in quadrant 3. And to get that one, we would first rotate 180 degrees plus 30 more, so 210 degrees. Okay, so those would be all the solutions that are between 0 and 360 degrees that solve this equation. Okay. Another important property in algebra for solving equations is the property called zero-factor property. So the zero-factor property says that if we are multiplying two things, as we are here, and that product is equal to 0, then one of those factors must be 0. So what ends up happening is usually if we have something that is written in factored form and it's equal to 0, we then set each of those factors to 0, and then we solve those factors for the variable. Okay, so in this equation, we can apply that here because notice that we have a cosine q factor here, we have a cosine q over here. So what I'm going to do is I'm going to set this to 0 first. So I'm going to move all the trig functions to one side. Then I see the common factor of cosine q that I can now factor out. And now I have that. I can apply the zero factor property because I have a product. So cosine q times cotangent q plus 1. I have a product that's equal to 0. So I can set each factor to 0. So when I do that, I get, okay, and then we end up with, when we do that, we end up with two linear equations that we can now solve for, or linear form, right? Two equations that are linear in form that we can now solve for q using the strategies that we saw in example number 1. All right, now for this first one, I want to find all the values of q such that the cosine of that will equal 0 between 0 and 360. Now, the value of 0 is important because that corresponds to a quadrantal angle for cosine. So think about, when is cosine equal to 0? That's right, so between 0 and 360. So cosine is equal to 0 at pi over 2. Well, and that would be 90 degrees. And also at 270 degrees. You can use your unit circle to figure that out. Now, for the second equation, we have, we want to first isolate the trig function, so cotangent q equals -1. And then we have to think to ourselves, okay, so where is cotangent negative first? So cotangent is negative in quadrant 2 and quadrant 4. Now we need to find the reference angle. You have to ask yourself, is -1 a common ratio for cotangent? Well, yes, it is. So 1 or -1 is a common ratio. So ignoring the negative for a moment, let's focus on the positive one. So when is cotangent equal to 1? Well, cotangent is equal to 1. If we go back up here to our special triangle in the last example, we see that cotangent will be 1 at 45 degrees. Right, so that's what we see here. So now that will be our reference angle. So our reference angle is 45 degrees. We now place the reference angle in the appropriate place, and then we solve for those measures. So for that first angle that's in quadrant 2, I would do 180 minus 45, so that's going to give me 135. And for the angle that's in quadrant 4, I would do 360 minus 45, that's going to give me 315. And that would give me all the values of q between 0 and 360 that solve this equation.